We talk a lot about the power of manufacturing simulation, that it offers strong visuals, it offers several features to have optimum planning for your manufacturing systems. But how does it really work? Today, in this video, we are going to divide the simulation workflow in simple steps, and let's go through these steps one by one with an example. Right, so we have a simulation model in front of us where we have the identical robot cells, and we see already the robot is picking up this green product that's coming through the conveyor, and it starts to place them into the machines. Once it's processed, it starts to store them or palletize them on top of this shelf and the white pallet. The forklift then picks them up and brings them close to the human workstations. Now we have two humans with individual workstations. They are picking one product at a time, finishing them and putting them back together on the same pallet. Then the forklift here picks them up and stores them in the buffers behind the robot cells. Now this is the functional model we have today, and what we are going to do is build this together in different steps. But before we do that, it's important to see what the workflow is and what are the steps. Before we build the simulation we just saw, it's important to understand different steps. So the first step we have is to design a static layout, meaning bringing all the 3D models into the workspace and positioning them in their right places. The second step is to model, meaning defining products, processes, and flows. We also call it process modeling, and we've already covered that in one of our previous videos in detail. So if you're interested, check out that video. The third step is to simulate. So basically making sure that all the processes are working as we planned. The next step is to analyze the performance of the simulation and collect statistics from that. Then comes the step where we need to optimize the simulation that we've created. So making sure that all the manufacturing assets are working to their full potential. The last step is then to share the simulations with your peers or your customers. Now this workflow may change based on your use case, so you might want to start with building the simulations and then sharing directly with your peers and customers, so skipping the analyze and optimize part, and then you want to come back and then change some data there and making sure that all the systems are working fine. But we'll go with the flow we have today, so let's go through these steps one by one and build the simulation that we just saw. Okay, we start with the design phase. So we have the software in front of us. This is how Visual Components looks like. There's a lot of UI and a lot of things here, but let's try to focus on the left panel. So we have the eCat here. So basically a library of components where we have all the 3D models. Let's bring in this feeder. Let's change its angle a little bit. Then you see all these folders. So let's bring up the conveyors in here. So we have the generic conveyors in the Visual Components folder. So let's bring that here. Let's rotate it and snap it to the conveyor, to the feeder. And let's bring in this crossing conveyor now. So you see all of this is kind of plug and play, very easy. You just snap things together. Then we have another conveyor. So let's try to interact with it a little bit. So when we interact with components, you see their dimensions and their properties start to change. And then it's not just limited to conveyors, it's also changed in robots and so on. So we got this conveyor a little bit longer. Let's clone it again. Now we have 3 conveyors and a couple of crossing conveyors. Let's bring this one crossing conveyors at the end, so because we need to have 2 inputs to the robot cells. Now as you see that when we rotate this conveyor, when you are trying to snap it to the previous components, it adapts the properties of that. So you don't really need to define the angle of each of your components one by one. It kind of adapts to the previous component. And that really helps with the design process. So now we need the machines. Let's bring in the parametric lathe machine. First change its angle. So we need to place it on each of the side of the conveyors. Here we change its angle. So let's take it to -90. That is correct. Let's change its size. So we also have predefined sizes. Let's actually bring this closer to the conveyor here. Now we need more machines than one. One nice way to do is that is this linear pattern feature, where basically you just clone the machines in several different directions. So let's clone this towards y-axis with certain values here, and we need 4 machines. So here we go. Now all of them are equidistant from each other. That's very useful feature to design quickly. Now we need another machine on this side of the conveyor. Let's change its angle, bring it closer, and let's have another one. So now we've got 6 machines as we had in the simulation that we saw earlier. Now we need a robot between these machines, and before the robot we also need a robot positioner. So let's click on that folder. Let's take one from Visual Components folder, this generic servo track. We need to change its angle, so let's change it to 90 and let's bring it between these machines. And now we also want that the robot reaches all the way towards the last machine, so let's change the robot positioner's length to 8000 millimeter. Now we need the robot. So before we take the robot that we want, here you see a lot of robot brands in here. So these are actually the brands that we all know with the real robot models in them. And that really helps to build a lot of simulations. So we have ABB, KUKA, Kawasaki, Fanuc, all of these brands in here and many more. Let's bring in the Visual Components generic robot first. So we have the robot now, we have the robot positioner. We know that the robot is going to reach all the way until the last machine. Now we need a generic shelf in here just to make sure that once the products are processed, they are placed on top of this. Here we place it right there. So we have a robot cell more or less complete now. Let's copy this whole cell and let's then paste it right there. So here we go. Easy peasy. Let's bring it here. So now we have two identical robot cells. This is how easy it is to design. Now we also need to make sure that the robot reaches. So here we have a nice feature called envelope where you see that the robot, whether it's reaching all the different places or not, and apparently it does. So here's the model that we've just designed. Just to make things a little bit faster, I did rest of this design offline, but the method and the workflow was exactly the same. So bringing all the components from the eCAD, placing them in the right places, and making sure that we have all the static pieces of the layout inside this 3D workspace. Before we move on to the next stage, I'd like to show you a preview of our eCAD. So our eCAD is one of the most diverse eCADs you'll ever find in simulation softwares. We have about 2,500 components, actually more than them, close to 2,600 components. By components, I mean 3D models that have simulation behaviors in them. So you can basically just drag them into the 3D workspace and start to build your layouts. Then we also have more than 50 layouts in our eCAD and with different use cases. So a lot of our user base likes to use these layouts instead of building something from scratch. And these layouts all have simulation behaviors assigned. So basically you just drag and drop the whole layout into the 3D workspace and play the button and simulation works. Then out of this 2,500 or almost 2,600 components, we have more than 1,600 robots in there from 70 different brands, so which we already saw in the previous step. So there's some of the examples of components we have. So we have conveyors, we have machines, we have resources, then we have robots, robot positioners. We also added one in the design phase. We have workpiece positioners, factory facilities. So all the components that you may need to build your simulations. Moving on to the next step. So this is model, where we need to model the products, processes, and flows. Now we have a palette in front of us that is white one here. And then let's bring this green part in the 3D workspace that we want to define as a second product. Now here you see at the top that we have products, processes, and flows. So let's start to define and start from products. We have this default product VC cylinder if there is no product defined. So it's as easy as picking a component from 3D workspace, and that's how the product is defined. Easy. So this is how we define the green one. Now let's add another product. So let's add a flow group, and we have product type. Let's change its name to palette. And again, we click on this box with the cursor and click this product, and that's how our second product is defined. So defining the products is quite easy. Then comes the processes. So we have a lot of processes in here. Let's zoom in and try to divide this layout into different sections. Let's look at this process. So whenever you click these processes, the blue ones, a pop-up window appears where you see the logic of these processes. So here we see from conveyor, which is basically transporting a product in and out. Then parametric lathe. So what we have in here is that product is transported in, we got some delay, then the machine door closes, then we have a cycle time, then machine door opens, and the product is transported out. So very simple logic in here. Let's look at palletizing. Let me bring that to the screen here. Now we have transport in, then there's a waiting property, then we've got the transport pattern. So basically how you want to palletize the product on top of a pallet. So you define all these properties in here, then you attach the part to the pallet, so the green part, and then it's transported out. And moving on, let's also actually look at this manual process. So if we click on that, let me bring that onto the screen. So here we have transport in, we have certain cycle times for each of these humans, and transport out. We have certain statements like idle and busy. These statements basically define and give us the properties when certain resource is idle or it's busy. So it kind of records all these states. Okay, so we've defined the processes. Now let's start to define the flows. So once we open this flow, we have the process flow editor here at the bottom as well. This is a panel where we can see the flows. So first, defining the flow, we need to pick the first process, that is from conveyor. Then the robot needs to pick the products up from here and place them into the machines. Once it's processed, the robot needs to put these products on top of pallet on this palletizing process. Then the forklift needs to pick this pallet up, bring them onto the depalletize. So here we click here, and then we switch off this controller of forklift. Then we want the humans to pick the products from this process one by one, bring them to the manual workstations, and once they are done, they need to bring them back and repalletize them on the repalletize process. So we see that the flows are easy to define. We also see that it's easy to track the flow logic of any layout, since all of this workflow is quite visual. There might be some clutter here and there, but when you start zooming in and out, you'll start to understand the flows very nicely and very easily. Okay, so let's move on to the next step, which is simulation. And here, this is very basic. So what we need to do is to make sure that the processes, products, flows that we defined earlier are correct and the simulation is working as we planned. So here we already see that the products are coming in nicely. The robot picks them up. It starts to bring them into the machines. Here we see that we've got a couple of machines still idle, so the robot picks these green products, bring them into the machine, and the door closes. This is where the cycle time starts. So far it's working fine. Let's increase the speed of this simulation just to make sure that everything is working fine. It actually does. Once the products are processed, the robot starts to palletize them onto this pallet, onto the shelf, and once this pallet is complete, here we go, the forklift picks them up and brings them next to the human workstations. And now we see the humans picking them and then working on them. Okay, so our simulation is working fine, which is great. Let's move on to the next step, that is analyze. So here we see that our layout that we built has production output defined, and we could see here that the output kind of is around 52 parts to 53 parts per hour. Now you can collect different kind of statistics from your layouts. You can collect the utilization of robots, you can collect the utilization of your machines, how much they've been idle, how much they've been running. You can also collect the distance traveled of humans, AGVs, you can collect charging times. There are tons of different possibilities that you can measure from your layouts. But here we try to stick to production output, and we see that we have about 54 parts here now. Now let's assume that a manufacturer has this setup and wants to ramp up the production output. So what are his options? Let's try to build these options in the next few steps, and let's try to see and understand how simulation starts to help with that. Okay, so we are on to the optimize part now, and this is where we are going to build some different scenarios and check how simulation starts to help to understand and maybe ramp up the production. What are the ways to do it? Here's one way, which is called scenario 1 in here, and now you see that there is a difference of production output. The production output here actually has increased to 74 parts from 52 to 53. How have we done that? So if you look closely, we've got this cobot next to the human workstations, and this cobot basically helps to reduce the cycle times of human finishing process, and based on that our production has improved to about 74 parts per hour. This is the first option, but there can be many others to ramp this production even more. So let's have a look at another scenario that we have. Or by the way, if you haven't noticed, we have this second cell that is not functional. And the reason why this is not working right now is because we have only 2 humans to help and work on the products that are coming from the lathe machines. So we don't have enough resources to cope up with productivity coming out of 2 robot cells. And that is another headache that manufacturers usually face, that they have manufacturing assets, they have all their setup working, but then there are certain places where they start to find the bottlenecks. And how do they make sure that all the elements are working together? So in the next scenario, we have added 4 human workers with 4 manual workstations. So each of them have their own manual workstation to work on. And we see that there's a clear difference and there's a massive increase in the production rate. So the production rate has improved all the way up to 162 to 63 parts per hour. This is one way to ramp the production up. And we see another factor of this scenario is that we have both the robot cells working. So from the generic overview, it looks like this is the most optimum scenario for this manufacturer. Or is it? There are many other factors that we haven't taken into account. So let's have a look at those in the results. Now here we have the summary of the different scenarios. First simulation, we had production rate about 53 parts per hour, but the second cell wasn't working. In the second scenario, we had 2 cobots and the production rate actually increased up to 74 parts per hour. So there was 40% increase in productivity compared to the first simulation, but the second cell was still not functional. And then in the third scenario, we had 6 workers. So the production rate went all the way up to 161 parts per hour. So huge increase there. Over 100% increase in productivity. We also had both the robot cells working. So another positive side of it. But one important point that we missed here was that there is 200% increase in operational costs or labor costs. So these are the scenarios that manufacturers usually have to work with. There's always some trade-off. There's always some situation where they have to be challenged with different scenarios and they have to pick up the best that works for them. And what simulation or manufacturing simulation does is it offers you a better perspective of your operations through a virtual environment and helps you make informed decisions for your setup. This is where simulation really helps and becomes handy. Moving on to the last step of the simulation workflow, which is to share what you've been working on with your customers or your colleagues. You can export your simulations into many different formats. So here we have some of them in front of us. We've got the 3D PDF where you can see the simulations running. It almost looks as if it was in the software, so it's all in animation mode. Then we've got on top right a nicely rendered image of one of the robot cells, so you could actually enhance your visuals of your simulations with different add-ons. One of the add-ons that we use to do for this is Blender. Then we've got on the bottom left a 2D drawing, which is quite commonly used in the manufacturing industry. And on the bottom right, we've got different camera angles of the same simulation. So it looks like as if a drone is flying over this layout. So we saw some of the examples of the content that you can create from your simulations. Here we have some more. So we saw 3D simulations with different camera angles. We saw 2D drawings. You can also export your images and videos from your simulations up to 4K quality. This becomes quite useful content when you are presenting your proposals and your simulations to your customers, or you want to share all your simulations in trade shows or seminars. Then we have 3D PDF animation. We also saw that. And you can also export your simulations to VR, and you can even watch them on your phones. Last but not the least, you can also export statistics and reports of your simulation studies that you've carried out from your simulations. I wanted to share with you how cool your simulations may look like if you start to use Blender add-on. Now this Blender add-on is available for free on Visual Components forum, and what it does is it enhances the visuals of your simulations to really good quality. So here we see KUKA robot spot welding a component on top of a car body, and then we have another example of a warehousing simulation where we have some buffers in there, and then we have some pallets moving around on conveyors. But your simulations that look perhaps ordinary in the software may look really cool if you start to use add-ons like this. When I mentioned earlier about exporting your simulations to VR and mobile phones, this is what I was referring to. So Visual Components Experience is a separate product that allows you to export your simulations into virtual reality. Now it offers you immersive and engaging experience, but not just that, it also helps you to walk around inside your virtual factories and helps you to give more insights into your systems and helps you find and optimize more bottlenecks. You can also export your simulations to your mobile phones. All you need to do is download the Visual Components Experience app from Google's Play Store or Apple Store. Then from Visual Components software, you can just export your simulations to mobile compatible format. That just takes a couple of clicks, and then you just need to upload that into your app, and that's how you can start to view all the simulations on your phone on the go. One nicer thing is that you don't really need to have software, you don't really need to have a PC next to you, you don't really need any special connections. That's all for today. Hope you learned about the manufacturing simulation workflow in different steps. So starting from design, modeling, simulation, analyzing, optimizing, sharing your results. If you want to start using Visual Components, get in touch with us through the link in the description. Together, we'll try to find the best plan that fits to your needs. Subscribe to our channel and see you in the next video.